Hello, I'm Jaden Santos, and for my physical geography final project, I chose Tokyo as my capital city, and I'll be focusing on the greater Tokyo metropolitan area for this project. Given the small nature of Tokyo, I figured doing the general area around it as well would be a better overall presentation. So we will first start with the introduction, starting with Tokyo's location. Tokyo is the capital city of Japan. Japan is one of the dominant countries in Asia. It sits at around 35 degrees latitude and 139 degrees longitude. It is a mid-latitude temperate zone, and the elevation ranges from sea level at 0 feet to roughly 2,000 meters or 6,600 feet. And here we have a zoom-in, punch-in map of Tokyo and the greater area around it, the metropolitan area surrounding it. And if you were to look on this map, it is this section of land right around here. So now we will move on to some rough information about Japan in general. In Tokyo, the predominant language is Japanese. The population is 9.7 million people in Tokyo. I'm not positive that is, or actually, I'm pretty certain that is just the city specifically. I'm not sure of the population of the entire metropolitan area. The major religions are Shintoism and Buddhism. The political system is a dominant party, bicameral, parliamentary, representative, democratic, constitutional monarchy. It's a bit of a mouthful, but this is a very similar system to what a lot of Europe runs on. A lot of the countries in Europe that still are monarchical or feature monarchies, they have this semi-democratic system, which is very similar to the UK or Britain, for example. Tokyo, the economy of Tokyo is very strong. Tokyo's gross regional product was over 100 trillion yen, which is roughly $1 trillion in 2021 alone, which accounted for over 20% of the country's entire economic output. So Tokyo is putting in a lot of work for Japan, and is a very dominant capital city in the world. Moving on to insolation and temperature, we will start with the seasons. The seasons would be experienced very similarly in both Boston and Tokyo, given the similar latitudes. Boston being around 42 degrees or a little higher than that, and Tokyo being around 35. And being both in the northern hemisphere, is going to give very similar weather and seasons. They're just going to be shifted, obviously. They wouldn't be shifted. But the day length in both cities is very, very similar. The only difference is Tokyo is a little bit longer, given it being closer to the equator by a handful of degrees. Moving on to temperature patterns. Here we have two temperature graphs throughout the year. Unfortunately, they are in different measurements. One's in Celsius and one is in Fahrenheit. Blame the imperial system, I suppose. However, we can just roughly estimate these, and using our understanding of where they are in the world. Tokyo is just a little bit warmer year-round than we are here in Massachusetts. Obviously, this is because they're closer to the equator, and they not only do they receive more sunlight throughout the year, they also have a more direct sun angle for longer, because they're so close to the equator. Additionally, you can note that both of these graphs are very similar in shape, and again, that's because of their similar latitude and both being in the northern hemisphere. So they're going to experience the seasons very similar, and temperature is going to be comparable throughout the year. Japan will always be warmer, but it will be comparable. Now, to talk more about weather and climate, here we have climagraphs for both Tokyo and Boston. Thankfully, these are both in the same measurement, so it's easier to compare. And you can see the temperature min and max is very similar as we saw before. But looking at precipitation, you can see that Boston has a more consistent precipitation throughout the year, while Tokyo has a obvious dry and wet season, as well as generally more precipitation. There's obviously certain times of the year where they receive less than us. However, overall, they do receive a bit more precipitation, just generally. Moving on to climate, we'll start with pressure and wind. Tokyo is predominantly affected by the subtropical high-pressure belt. This causes drier and generally clearer weather throughout the year. They're also affected by continuous westerly winds, which bring in that humidity and warm air, which can, or which potentially is influencing their precipitation throughout the year, and that can cause these drastic wet seasons and dry seasons throughout the year. The Köppen classification for Tokyo, or I guess Japan in general, is a temperate zone, specifically humid subtropical climate, which is designated as CFA, which is the same as here in most of New England and Boston specifically, or our area specifically of Massachusetts, the southeast region, and more or less. Comparing the climate to other areas of the world, it's very similar climate to the majority of Western Europe, excluding like Spain and Portugal, who have drier, warmer weather throughout the year. It's very similar to China. Obviously, they're incredibly close to each other on the world, and are roughly at the same latitude. And as well as a lot of the southeast United States has this humid subtropical climate. And then here's just a nice photo of Tokyo to get an idea of how it is. Moving on to weather, as we talked about before about precipitation, that Tokyo has a predominant dry and wet season. Late summer, early autumn is typically the wettest season in Tokyo, where they get the most rain and the most precipitation. And winter is the driest season, January, February, March. Moving on to severe weather, Tokyo has experienced tornadoes in the past. However, it is relatively infrequent. It is more frequent in other parts of Japan, predominantly the flatter, longer areas in the south. Tokyo is not a top 500 hotspot for lightning in the world. However, they do experience typhoons very regularly. Typhoons are their equivalent to hurricanes. And Tokyo was actually hit by what I believe to be the strongest typhoon to ever hit Japan in recorded history. The Reiwa 1 East Japan typhoon hit in October of 2019. This photo is of that time. You can see the flooding is in this area alone, coming up over a bridge here. And it caused over $17 billion in damages. And it took over 100 lives. So they have incredibly deadly storms. That is just an aspect of being along the coast. We obviously experience hurricanes and tropical storms often as well. This is just a facet of living along just specific tidal currents or specific ocean currents, and just as climate change is affecting our world, we're seeing these increased storms. The deadliness of storms is only increasing. So this is something that Japan is well versed in. And as of December 2nd, 2024, Tokyo is experiencing nominal weather. Everything is as it is expected to be. So from here, we'll move on to the mapping section of the project. Here's a map of the lithology of Japan, focusing on Tokyo. Starting with the age of rock, it's majority quaternary rock in Tokyo itself, and then once you get out, you start seeing some more Paleozoic, Mesozoic rock, as well as some outcroppings of exclusively Mesozoic rock, and then you see a lot of Cenozoic rock and rock from the Neogene period. This can be attributed to the the volcanic activity in the area. As you can see on this map, there's a lot of volcanic rock and intrusive rock in this area, which is due to the fact of this landform being relatively new, given the volcanic activity that created Japan itself. And much of the rest of Japan is similar to this, where it's a lot of sparse rock mixed in with other types of rock. However, it's all relatively new compared to some other areas of the world where you see a lot of Precambrian rock. Moving on to plate tectonics, Japan and Tokyo, obviously a major earthquake center of the world. We'll get onto that in the next slide. However, Tokyo sits on the Eurasian plate. It's south of the Yamato Basin spreading center. It is north of a transform fault belt, Ryukyu and Bonin. These are trenches. And it is northeast of the Nankai Trough. The Nankai Trough being this subduction zone right here. And then we have this convergent boundary that goes right between Japan and is just southeast of Tokyo. Tokyo is roughly where this movement vector is located. It's this general area here. This is Tokyo Bay. So there are a handful of major boundaries all around Tokyo, and this large subduction zone here is a section of the Pacific Ring of Fire, which obviously extends all the way around to the west coast of the United States. Moving on to earthquakes, Japan and Tokyo experiences earthquakes incredibly frequently. The most recent large earthquakes were in November of 2024, all around 4.5 to 5 magnitude, all similar depth ranging from 50 kilometers to 70 kilometers. Two of them were early morning, 10 a.m., and one was late night, late afternoon, around 1 p.m. Two of these were on the same day, the 4.5 and 4.9 magnitude, which was an incredibly devastating day for Tokyo. And then these are just general areas that were given from the map source we were provided for earthquakes from Dr. Bolstroff. And these are all generally around Tokyo. If anything, they're all a little east of Tokyo. Next, we have stream discharge. Here's a photo of the Ara River in Tokyo. This is the section of the Tokyo Bay, or of the Ara River in the Tokyo Bay. This obviously is the output to the ocean. So this sees a lot of throughput and discharge at 47 cubic meters per second. It is a lot of water, and it is a massive drainage area, over 3,000 square kilometers. The Taunton River near Bridgewater is a measly 1 cubic meter per second as of December 1st. These are both taken from December 1st. We know, and I've talked about in our class, we're experiencing a drought in this part of the world. In this part is Massachusetts. So this is to be expected, being very low. If you were to go to the mouth of the Taunton River, it is roughly 3 meters cubed per second. So it's not a lot of water in the Taunton River right now, but the Ara River is incredibly productive. Lastly, we have coastal protected area. There's over 96,000 square kilometers of marine protected land in Japan, and you can see here there's a significant amount of marine protected land around Tokyo. This is obviously the central Tokyo here and the greater Tokyo area, and there's a lot of protected area. South of this, there's a large trench that is additionally protected. And then some extra information. There's over 100,000 square kilometers of protected terrestrial land in Japan, which is about 20%, I believe, of their land mass. So Japan is doing a good job at conserving their land, which is a nice thing to see. Here are my sources. Thank you very much.